Okay, well, welcome to September TriEmbed meeting. Um, Welcome everyone. I don't see any new folks that need introduction. Uh, who'd we lose?
Pete may be joining us. I spoke to him a little while ago.
Okay, Haven. Okay. Um, so announcements, things going on. I sent an email to the mailing list about the Alamance Makers Guild. They have a couple of meetings. They have a video production group. They have a microprocessor group, and then they have a makers, general makers meeting as well. Um, I've been to a couple of their meetings in Burlington at the museum, at the library downtown. Some of their meetings are virtual, some are in person.
Didn't get anything. I didn't do anything.
Carl's back. I started the recording, Carl. I'm so we're doing announcements. I mentioned the
And I can cut
Alamance.
out all of this later.
Yeah, I mentioned the Alamance Makers Guild in Burlington that I sent the email out to the list. Anything else going on? Oh, PCB Carolina is at the McKimmon Center at State on November, I believe it's the 8th, all day Wednesday. A number of us have been going to that uh, for many, many years. Anything else going on? We have a Edger meeting next Wednesday.
I think it's
This
this
Wednesday.
Wednesday.
This Wednesday, 2 nights from tonight, at the Forge plus online on this channel. So I spent most of this afternoon working on my Hummingbird presentation for tonight, and I kind of totally forgot about doing a problem of the month, but I have one in reserve. So,
You keep problems in reserve. A good idea.
well, it was for the month when you and I were the only ones who attended, Nick. So I just postponed that. All right. Do people see that?
Yes.
All right. So this one is more of a software problem than we normally do, but so as many of you know, I play pickleball several times a week. And I play at the Raleigh Parks and Recreation rec centers, several of them. And they currently use a clipboard with a piece of paper on it, having multiple boxes. Each box has 4 lines in it. And so you write down 4 people's names to sign up for a court. And as a court becomes available, the next 4 people on the list take the court. While you're waiting, people are chatting up in the, there's some bleachers or something. People are chatting away and not listening to what goes on. So somebody has the clipboard and they have to read out the 4 names. They were chicken scratched in and sometimes hard to read. People will do substitutions and say, "Oh, I don't want to play with these guys. I want to play with these guys," and they'll scratch out their name, and somebody will try to write a name in on whatever little space is left, and then 4 people will jump up and play the next game, but nobody will cross them off the list. So it's very confusing. So generally, there's no Wi-Fi or internet that I'm aware of. And it would be nice if I could use the hardware from my pickleball scoring display unit that I've been working on. And maybe some kind of a cell phone. A lot of people have cell phones. Players to come play get a barcode from the city that they scan in at the front desk that allows them to come play. It's $10 for 4 months of open play. And so I'd like to have some kind of a waiting list program. Probably that you could look at on your phone. You can see who's up next. You can see how many games, are ahead of you. And maybe automate the the management of the list. It'd be great if it could estimate wait times, measure how long each game took, and then apply the average of that as to the number of games between you and the next court that's come available. How many games you played, how much time you were spent sitting in the stands. Some people have a partner they want to play with all the time, so they want to wait for 2 slots to be available in one of these boxes. Some people like to play all 4 together, so they have to wait for an empty box before they can put their names in. If we had a little barcode scanner, we could scan the barcodes that people checked in with and have a little database that remembers people's names and their preferences for who they want to play with and things like that. So any ideas on how we might do something like this?
Have you looked at the town of Carey's pickleball booking system?
I have not.
I mean, someone else must have solved this.
I'm sure they did have.
You have an ESP32. You can just put it into the server mode, and then you'd have a web page.
You can do that with a 8266 as well, but okay. Yep. So you can host a web page. You can have QR code that a camera can scan that will allow them to pick up the SSID and passphrase for your little host there and log in. Not everyone has Android or iPhone, right? So you're going to have to support both, which means you probably want to do something that's purely browser based as opposed to writing
Yeah,
an
you
app.
need you just it's a web program. It doesn't matter so much what machine it runs on.
Right.
It could well be a MicroPython program. It doesn't sound complicated. Could be a regular Python code.
To generate the web pages
Yep.
that you serve to the devices.
Well, where would you serve it from?
A device that you carry to the stands in the rec center.
Oh, so you would just be serving it locally and then the server would be shut down later on.
Yep. You can't. You can do a little bit of a database on an SD card, I guess, for your ESP32.
A little bit of security. You're going to have people trying to hack it.
Okay. You think? What are they
I
going to
know
hack? You know they are.
they'll try and hack the server if you don't have correct.
It's not connected to the internet.
Well, how are they? How then? Who's going to be able to use it?
People that have cell phones within range of the access point being served by the ESP32. So people in the stands.
Okay. So what radio on their phone is going? I mean, what are you putting it out on?
Wi-Fi.
Oh, so you're going to create a Wi-Fi and people would have to connect to the Wi-Fi.
Right. And you can do that with a QR code, so you don't have to spell out what the SSID and the password are. Right. So they come up and they scan the QR code. I guess it would have to be two: one to join the network and one to access the web page.
And there are the ESP camera has things that will scan QR codes. So if you use one of the ESPs with a camera, then you could not only display the QR code, but they could log in with their QR code. But they have a barcode, right?
Yeah. Yeah. Oh, I see. Okay. Yeah. So you could read the barcode. I bought. So I'm supposed to click on me. Is that what you're saying, Carl?
Yeah, if you click on
Yeah.
you,
Okay. So I bought.
so we can't tell the difference here, but your
Yeah.
screen will, and that's what's being recorded.
Okay. So this is a little USB barcode scanner, and it acts like a keyboard. Back to tab.
Yeah, I don't know where that came from.
Richard, did you do something? So it acts like a keyboard, and it types the digits from the QR code into the keyboard buffer. And so if you do it while somebody has the right focus on a Windows machine like Notepad or whatever, it'll go into Notepad. I assume that we could figure out how to capture that on ESP32 somehow as well.
Well, I just use the ESP32 with a camera. I mean, they've got
Yep.
that's simple enough, and they can log in with their barcode, and then you just need a simple grid thing. The code becomes fairly simple then. Um, they don't have to enter anything. They just it's um,
So when a game is finished, the four people would have to return to their cell phones to sign up for their next game.
well, they're finished because your scoring thing will tell you they're finished.
Yeah, eventually with multiple courts. If you got 6 courts running, that's good. They got to buy six of my machines, right? All right. Any other ideas or thoughts on the waiting list sharing? Nick thinks it's relatively straightforward.
Well, for somebody else to do, yes.
And then you have to get buy-in by all the people that are there. That's probably the hardest part.
Well, but if they don't want to connect, they just don't connect, right?
Yeah, but they want to play, so they'll write their names on the clipboard. And now what do you do?
Mm.
I guess you have some number of boxes that on the clipboard you write and say, this one is on the app, and this one's on the app, and then this one's available. I'm going to start my presentation on the Hummingbird stuff. So, a month ago, I guess, August,
Yeah, this was
we had
most
problem of the
recent.
month was how can I monitor the nectar level in my hummingbird feeder? And after we had discussed it for a while, I presented my implementation because I'd already done it. And I had some preliminary results, but these are much better. So this is, about 3 weeks worth of data. And you can see the weight. The y-axis is of unknown units. At the bottom of the page is about 125 grams. At the top of the graph is about a kilogram. But you can see it coming down near the bottom. I add nectar to it. It jumps back up. It goes back down, up and down several times. So I'm refilling it every 3 or 4 days. One thing you may notice is there are a lot of these steps, and that's during the night. The hummingbirds aren't sucking out the nectar. So, this is a night, this is a night, this is a night. A couple of, little zigzaggies that aren't explained. Sometimes it went up. Those probably correlate to previous slide. Rain. If you look at the top of this, where the thing attaches to the poles, there's actually a little cup up there that can collect water. And that's by design. If you get a little pool of water in there, then ants that try to climb up and climb down reach this puddle of water and turn around. Okay. Without the puddle of water, they climb out and get the nectar and take it back to the nest. And so you get a line of ants. And the hummingbirds will try to pick the ants off the flowers, not to eat them, but to get them
I
away.
thought you said this wasn't integrated. Shouldn't that be equal for the ants and the hummingbirds?
Well, you might think that. So this thing is out on this pole. It's powered by a LiPo battery, and we want to minimize how much power we use, right? So we want to minimize how long we're awake. We want to minimize, we want to minimize how much we use the radio to talk to Wi-Fi. And so there's a facility called ESP Now, developed by Espressif, that uses some custom Wi-Fi packets. And so it's a vendor-specific Wi-Fi packet. And they use it to communicate small amounts of information between Espressif devices. And it's fast. You don't have to connect to a Wi-Fi access point. So we can wake up, we can do a measurement, send it by ESP Now, and go back to sleep in 40 or 50 milliseconds. But you have to have somebody that's listening all the time. And so in my garage, I have a little ESP8266 that's sitting there listening for ESP Now packets. It's USB powered, so no problem having it running all the time. And these masters, so I have one that measures the resistance between two nails in a pot with a lemon tree in it. And it wakes up, measures the resistance, shoots the data out, and goes back to sleep. The same thing happens with my Hummingbird. And so it sends 6 bytes by ESP Now. The slave that's listening for that converts those 6 bytes into a JSON string that is sent as the message to a topic that's telemetry / the device ID. These are the lower 3 bytes of the MAC address / sensor. So that's the topic name. And this is the message payload. And it's a JSON string that has 3 2-byte integers in it. For the Hummingbird Feeder, this I think I have on the next slide. S0 is the battery. S1 is 16 bits of the 24-bit D to A reading from the load cell that the Hummingbird Feeder is hanging from. And I've chosen these bits such that the S2 is always all Fs. So it's 4 or 5 bits of the upper 4 or 5 upper bits, and then it's Sine extended out to a 16-bit guy. So if I have properly architected my home Internet of Things stuff, adding a new device like this should be pretty simple. And so I have a Python script that has these objects. I think that's the right name. Maybe they're classes. So this one is a generic.
Everything's an object.
Okay. Oh, shoot, come on. Previous. Don't double click. So handler is an instance, right? It's an object which is an instance of this class, the generic class, which has in its constructor, I may be using C++ terms instead of Python terms. So
Yes,
that's
they use constructor.
okay. So that's the MQTT topic that it's going to monitor. It goes into the standard metering queue. I forget what the one is. I think it's how many messages it expects to get per hour. So that really should be 4 because I'm doing it every 15 minutes. MPH is not miles per hour, but it's messages per hour. So the H is home. So home.messages per hour. So this thing keeps track of how many messages were posted to this topic and posts it to this other topic. It's got a name that probably doesn't matter. It says, okay, from that topic, when you get a message, parse the JSON string, find the S0 field, and take the value of it and send it up to io.adafruit.com to this topic with the value that you extracted. So this pulls out the battery value, sends it up. This pulls out that middle value, sends it up. And then this says, okay, take that handler object and add it to the list of things that the MQTT monitor class monitors. So that wasn't too bad. So io.adafruit.com has an MQTT interface, but like normal brokers, they get a message to a topic. They look to see if anybody is subscribed to that topic, and if they are, they send that message to all of those, all the subscribers. There's something called a retained topic. If it's retained, the MQTT broker will keep the last one message. Adafruit, however, will retain all the messages posted to a topic for 30 days for the free plan and 60 days if you pay them a little bit of money every year. And then this allows you to create dashboards that graph values over time. And so this is, I think, 7 days of data from the pump house temperature sensors out at the horse farm. They got sent up to Adafruit. Yeah, so I wanted to also, so now that I'm collecting this data, I want to be able to see how full the Hummingbird feeder is. Sometimes I can look out the window and I can see the level, but not always. And I don't want to have to go to the computer. I especially don't want to have to bring up my cell phone and log into Adafruit or something. So I want a little display that I can sit in the kitchen window that when I'm looking out at the Hummingbird feeder to see if there are any hummingbirds at it, it will tell me what the current level is and maybe some number of last values so that I can see what that line is looking like. I've noticed that today the line has been pretty much flat. I have not seen a hummingbird since the big blow we had as the hurricane came by. So I don't know if they sensed that and took it as a indication to get out of town or not. We'll see.
I was going to say maybe they all got blown away.
Maybe they got blown away or started their migration early. So being on the windowsill, I'd rather not have a cord running. So I'm going to try to use a battery. If I'm going to use MQTT, I've got to hook up to Wi-Fi. If I try to do that continuously, the battery's not going to last very long. And I'm going to have to be constantly recharging it with a cord. So that's not what I want to do. And, the signal I'm trying to monitor gets updated once every 15 minutes. So this little display has nothing to do for 14.99 minutes out of every 15 minutes. So it should be asleep and wake up occasionally, see what the hummingbird data currently is, and graph it that way. I've always wanted to try out one of these ePaper displays. They hold their image even when the power is off when they're sleeping. And so it seemed like a good fit. And so I ordered one of these on Amazon. It's a 2.9-inch diagonal measurement. And, I splurged and got the 3-color one instead of the 2-color one. I'm going to use a D1 Mini Pro just like I did out in the Hummingbird sensor. And so here is an example of the display that I've been working on. This is the trend line of the weight of the feeder. It was low. I filled it up. Probably went off the top of the screen. I might have a little bit of scaling to do here. It came down. This is probably overnight. And then it came down some more. These little battery logos are the battery reading out at the Hummingbird Feeder. And this is the battery reading of the D1 Mini that's powering the display. So I'm still kind of in the process of doing the mechanical. I got a little PCB being manufactured at Osh Park. That's a shield that plugs into the D1 Mini Pro. And then I'm going to probably laser cut some 1/8-inch birch plywood to screw the display to and the processor. Make some kind of legs. The display will wake up every 9 minutes, 7.5 minutes, 14 minutes. It's got to be more often than every 15 minutes because we don't want to miss updates from the feeder. We're almost guaranteed that we will not be awake when the feeder publishes the message to the topic. But as I mentioned earlier, there is an option with MQTT to make a topic be retained. And for a topic that's retained, whenever a client subscribes to that topic, it gets a copy of the most recent message. We want to be able to tell the difference between message N and message N plus 1. We can't be guaranteed that the battery voltage and the weight will have changed. So I created another Python script that also subscribes to that same telemetry topic, and it parses out the values and dumps the data to a local text file. I can keep that file around and suck it into Excel if I want to do other plotting. If I want to look back historically, what I'm dumping doesn't have any timestamps, but I could add that, I guess. And then you see in the middle here, the 16, 17, 18, 19, that's the little counter that I added so that I can tell the difference between consecutive entries that might have the same first and third fields, and also gives me the opportunity that if the display wakes up and the last one I saw was 17 and the one it sees now is 19, it can know that it missed one in the middle or two in the middle or however many, and do something appropriate on the display. Maybe draw those in red or not draw them or whatever. And so in addition to dumping it to this text file, it also sends it to the local MQTT broker as the retained topic so that when the display wakes up, it can fetch this and look at it and decide if it's still in sync and what the current values are. So sometimes it's going to wake up and it's going to see the same value it got the last time. And for that, it just says, okay, and goes back to sleep. So I'm saving 256 data points. I have scaled them from 2-byte values down to 1-byte values, since that's the smaller dimension of the display and there's only 128 pixels, and so I don't need fractional pixel. So 256 bytes. It takes 256 divided by 4, which is 64 hours, which is 2.5 days to fill up the ring buffer with data. And as I restart the program, I would really rather not have to wait 2.5 days to see all the data. And so I put in this little replay mechanism. So the display can, when it wakes up and it sees that it's out of sync, for example, or it's missed too many data points, or the last thing that the display saw was 17 and the current one is 204, it can say, oh, something's really messed up. So it can send an MQTT message to a special topic and ask for a data dump. And that script that is dumping the data can where did I oh, there it is, tail. Yeah. So that Python script can do a tail minus 256 of this text file that it's been creating, and suck that in and send that out again as new data that the display can use to fill up the ring buffer with historical data, and it can catch up very quickly.
I have a question.
Yeah.
So in the ring buffer, you have data that you may not have seen yet. And like you said, you don't want to wait, 2.5 days. When you read it, any data that you read, do you remove that data from the ring buffer?
So when the display asks for a replay, that script is going to send 256 values, assuming that the file is that long, which by now it is, and that will totally overwrite everything in the ring buffer.
Okay. The reason why I ask is if you were to do a replay more than once, how would you be sure you're not actually seeing the same data? But if you're blowing it away each time, then that solves the problem.
Yeah. So it just totally overwrites everything in the ring buffer and keeps track of where the pointer is for the last one that was seen. So I still need, I have these scripts that parse the messages, and I need to figure out some thresholds, when the hummingbird weight gets below 20,000, whatever those units are, it's time to think about putting more sugar water in. And so that would be a good time to send a push notification to my cell phone. I do that for some other activities that happen in my networks. So I already have code for doing that. I have to be sure I set it up so that I don't get notifications every 15 minutes until I refill it. But maybe more than one would be a good idea. One an hour or one every 3 hours or something. And then similar things for as the batteries die down. I will show. Let's see if I can. So this is io.adafruit.com. These are all of my feeds or my topics, if you will. H is the home. So here is the hummingbird count. These are some earlier attempts where I was using different 16 bits out of the data. Here it actually wrapped around and that upper thing lost a bit. But if we look at the battery count, this is a nice plot for battery. I'm liking that. What happened here is I brought the unit in and plugged it into USB while I was making some code changes. And while I was doing that, it recharged the battery a little bit. And then it continued its descent down. At here, it stopped working. So I ran the battery all the way down. So somewhere in the 920 range will be my threshold for saying it's time to recharge the battery. Yeah. So here I brought it in, recharged it, took it back out. It's a nice, pretty much straight line. I was a little surprised at how nice and even it is. Some batteries have a big flat spot and then a sharp drop off, like lead acid ones do. I think. So I was expecting a not as nice of a line on the battery numbers.
Well, these are lithium ion, right?
That's correct.
Yeah, well, that's the reason why, because the electronics on the device, once it gets below 3 volts, it just shuts it off.
Right.
So you're going to see an even uh, uh, graph going down until it hits 3 volts and it just stops. So you won't see any crazy business, because if you did, that means the thing was overheating and blowing up your bird feeder.
Okay.
I have two things that might help a little bit. I have a solar cell. This is a flexible solar cell, which is but what might be a little more interesting is I have these, which are 6 milliampere solar cells.
6 milliamp solar cells. Okay.
So you might be able to put one of these and keep the thing charged in the sunlight.
So you'd need some circuitry, right? That does all that.
Yeah.
You'll have to check. I think these put out open circuit 6 volts, which means I would run them directly into the LiPo battery and use the LiPo battery as the regulator.
Yeah.
Well, I don't think that's a good idea. LiPo batteries generally are very, very picky about overvoltaging and then causing thermal runaway problems. So you don't want to, you'd need a regulator to keep the thing at about 4.2. BMS is probably the best idea, battery management system.
Well, there are some energy harvesting circuits that will harvest if this goes below. But if you're going to be at the meeting Wednesday, I'll provide one of these, and you can
Think about it. Okay.
Take a look at it. They're small,
Indeed.
and I have a a couple energy harvesting circuits. One of them was I got at the last circuit board meeting last year. They gave me one. It was called EB or something like that. There was a company giving them that had a table there, and they gave me one of them. I'm very good at scrounging stuff. So
Right.
it is if they are there again, then I would I'll scrounge, but you
Scrounge some more.
you'll have to scrounge on by yourself. But just be advised that that way, if the voltage goes down below the um, they'll harvest off half a volt and boost it up to something that'll charge the battery.
Yeah. So the D1 Mini Pro has some circuitry on it to switch between USB power and battery power, and it has charging circuits to charge the LiPo battery while it's on USB power.
You
And
might be able to
so,
fire this just into the USB power. I mean, I don't know what the quiescent is on the whatever the associated circuit is, but
yeah.
certainly worth a try.
All right. Any other questions? All right. Who's next for show and tell?
I scored off eBay for $30 plus shipping a rather nice linear technology board with a Xilinx 1 mega cell FPGA and a 16-bit 170 megahertz A to D converter, which for $30 is kind of a nice thing. So it's this is designed for a software defined radio, but you can run signals in and it gives you a digital scope with 16 bits resolution and 170 megahertz sample rate, which is not bad for $30. Now just got to get around to using it.
Is there any documentation, or do you have to?
No, there's no case. What do you mean case? What is this
No,
crazy talk?
not case. Documentation.
Yeah. Oh no, I've got documentation software. Um, it's extensively. It's an analog devices linear technology development board. They have Windows drivers. They'll do Fourier transforms. Um, it's It's got extensive libraries.
Okay. All right. Anybody else? So when I was, let me click back here. When I was doing the ePaper display using a third-party library, so you do an operation like clear, and then in the library there is a wait for idle call, and then you say here's the black data and wait for idle, and here's the red data and wait for idle, and then it's all supposed to show up. And it wasn't quite working, so I ended up putting in software delays because the refresh of the display takes maybe
Forever.
8 seconds or something, and it's flashing and flashing, and so I ended up hooking up a scope. Let me see if I can. So this is my little scope and digital analyzer, logic analyzer. So the red trace is supposed to be a digital output of the display board. It's the busy pin. And up here is about 3.3 volts, a little bit below. But the kind of zero is at 1.7 volts, and it's kind of noisy. And then sometimes it goes down to, maybe 0.9 volts or something. Doesn't look very digital to me. Doesn't look very digital to my logic analyzer that sees it fluctuating all over the place. Um, so I just thought that was interesting. So I pretty much ignore the busy output pin of the device and just hard coded some delays that seem to be long enough. All right, I got one more to show if nobody else is.
Sure, go for it.
So I saw this thing pop up, Google targeted ad. Let's see if I can find. It was a little battery tester, for AA cells. It was $6. So I said, what the heck? I'll give it a try. So it's a universal battery checker for 1.5 volt batteries and 9-volt batteries. It's got these little claws that you grip the battery with. It's got some other little contacts for the 9-volt. And so I said, cool, for $6, I'll give it a try. Well, so I pulled some dead batteries from my battery recycling tray, and it said almost all of them were good. There was one that was leaking alkaline white crystals that it said was bad, but all the rest of them it said was good. And I figured out all it is a voltage tester with no load across the battery. And so if under no load your battery reads 1.5 volts, then it says it's a good battery. And if it doesn't, it says it's a bad battery. But
That's not really very helpful.
no, it's not. I thought, come on.
It's just over optimistic.
Yeah. So if you want to power the device
So,
that requires zero current,
so I bought a few devices and I've yet to actually put them together and use them that are made for testing rechargeable batteries. You can either use them for nickel metal hydride or lithium ion. I think there's a little switch in there, and these actually do put a load on, because the way you're supposed to test it is fully charge the battery, put it in this thing, and it'll discharge it like super fast. In other words, it's really pulling current out.
okay.
A very low resistance resistor, which is like 10 or 15 watts that you need to put across it, or something. You kind of have to wire it together a little bit.
Yep.
And it's supposed to test a couple of things. But basically how long it takes to discharge the battery at what current, and that'll tell you how good the battery is.
The capacity when it's fully charged. Yep.
Yeah, from fully charged to like basically useless.
Yep.
And how long that takes and what the current draw was. So the current draw is going to change over time.
Yeah.
But actually, lithium ion, the current draw may not change over time, but they will with a nickel metal hydride. So, but I really do need at some point to sit down and wire these things together and actually start testing some batteries. But
So what I normally use is this little device. It's a 12-volt battery for a golf cart, I think. Not battery, a 12-volt bulb. So it's a light bulb with a little tail that has a thing, and it's long enough that I can stick one end on one end of the battery and one end on the other. Right? And if it's a good battery, I will see the center of the little nichrome filament warm up from silver to orange. Right? And it's not a bright light at any, in any regard, but it will warm up to orange. And so that's the load that I normally put across my batteries to decide if they're good or not. And of course, all these that it said were just fine at
Well,
1 and
what
2
is
volts. Yeah, question?
No, I was just wondering what is the normal like volt multimeter? Does it put some load on there? Because like almost
No.
all the time when my batteries are dead, I'll put them on there and it'll be like, go down to 1.2, 1.1, 0.8. Like I'll see the measured voltage decrease, and like that's pretty much a good measurement for me as whether it's a good battery.
yeah, well, unless you have a Heisenberg compensator built into the thing, it's going to draw some load.
Well, yeah, but it should be pretty low.
Yeah, it's pretty low.
Right.
It's a high resistance load, but
Yeah.
here's the one I have for lithium. This was a lithium ion tester. So one side is a lithium ion battery that you use to power the circuit, and the other one is the test battery. It says on the back which one is which. Battery, power supply battery, test battery on the back. So that's the test whoops, here, get that back in the camera there. That's a test battery, and that's the power supply battery.
Oh, I see those big wire-wound resistors at the bottom.
Yeah. So these are 8 ohms. They're in series. I can tell from the way the clad is on the back. You may not see that, but there's a split in there between these 2 pins on this side. I don't know if you can get that. Probably can't really get that, but yeah, there are big heavy resistors in there. These are 10 watts.
Yeah.
8 ohms at 10 watts.
So on the high end of things, you can buy what's called an electronic load, and they're often programmable, and you can apply a load to the battery with different parameters. For example, constant current, constant power, constant voltage, and the thing will adjust itself to impose a load on the battery, and there's often a mode that you can put it into that will answer the question, how many ampere hours are in this battery? And you get to pick the load that you want to impose on it. So if your application takes 20 milliamperes, you can just dial that in and say, okay, run this thing with a 20 milliampere constant current load until the voltage drops below X.
Yep.
And it will tally everything up and tell you, just how much total energy is in the battery. The drawback is it's relatively expensive.
Probably costs more than $6, right?
Yeah, the one I have is about 500 or 600.
Yep. but it works.
It's really good, and it'll dissipate from memory. I can't remember. I think it's 150 watts, and it's a handy piece of equipment, but it would be, I think it would be straightforward to make
What we need, right?
something that gets you about 80% of that functionality with with a microprocessor and some FETs and so on. You guys have probably seen electronic loads that are relatively cheap, that you can use.
Yeah. If you
Yeah,
put a
that just
MOSFET on a pretty big heat sink and you could use it in its linear range as a variable resistor and use that actually as a variable load, but
yeah,
it's going to
and
get hot.
right, and I have a couple of those. They're not very expensive, maybe 20-30 bucks. And it's exactly like you described. It's a FET bolted to a heat sink with a 9-volt battery and a bit of electronics and a knob. And when you turn that knob, you can basically adjust the load that you're creating. So but in my mind, the fundamental test of a battery is how does it behave when it's under load. So the battery testers that don't actually give you a realistic load, in my opinion, are completely worthless.
Completely.
They're well, I mean, they're not answering any question that's relevant to your application.
That's right.
Well, it makes me wonder, Paul, did you take it apart? Did you see
I
what kind
have
of
not
load it
yet.
has?
It does have Phillips screws, so I'll do that. So I took one of my bad batteries. I'm measuring it with a voltmeter, and I get 1.2 volts.
Oh, yeah, that's bad.
Um,
Yeah.
but it's very constant,
Yeah.
1.189.
That's
So I
not
don't
a,
see it. I don't see it going down. I guess if I kept it on here for an hour, it would probably go down. But
But
I'm
those
not.
alkalines, if they're good, they're going to be over 1.5. It'll probably be like
yeah,
1.5 or something. Now, some of the
nickel metal
NiCad, some
hydride.
of nickel metal
NiCads are
hydride, they might be 1
1.25
point. Yeah, yeah.
or so.
1.2 is nominal for that.
Yeah, I mean, right. So this one, if I put it in the battery tester, it says it's in the yellow, which is between the green good and the red bad. So let me try a different one. This one's up high in the green. It's reading 1.4, but if I put a load on it, I don't know if I can get all my things together. We'll see. 0.7 under load. So that's not a good battery.
Have you tried to charge it?
No, it's an alkaline.
Oh, you can't. Okay. Yeah,
I've
that's garbage.
I've trashed it. Not trashed it. So when I worked at NVIDIA, they had battery recycling, and they would take alkaline batteries. And so I got in the habit of sticking all my dead batteries in a little bucket. And so I still have them, even though I don't work at NVIDIA anymore. Figure maybe when COVID was over, I'd be able to come back and dump all my batteries in their recycling bin.
Well, I don't know how it is in where you live in Wayne County. I mean, in Orange County, we have. If you just drive to the place, they have the solid waste place. They have a little
Thing for
repository for
batteries.
them. Yep,
Okay.
Yeah,
alkaline and rechargeable.
yeah, Wake has those.
Okay.
but I only one is in the ridiculously north Raleigh section, way north, and then the other is way south. So you've got your pick of Smithfield Road in Apex, and I've forgotten the name of the road.
DuPont Road or something.
Something like that, off of
Or,
Capitol. It's
yeah.
401 or something. It's
Yeah.
halfway to Wake Forest.
Right.
I wanted to loop back to the lithium battery charging one for a second.
Okay.
Does anybody know whether or not it's the case now that it's hard to find a lithium ion battery that doesn't have protection circuitry in it? I mean, way back, there were cheapo lithium batteries that didn't have the protection, and they were basically little thermite bombs waiting to go off if you overvolted them. But nowadays, I'm curious, these little tiny lithium ions that you see powering um, microprocessors and so on, that are order of magnitude an inch by an inch and a half, and so on. Does anybody know if they
They all have the
They've got to if it's a
protection.
piece of electronic equipment, they've got to have a circuit in it to do it. A
okay,
BMS.
so
So here's a little LiPo
yeah,
battery with 80 milliamp hours in it or something, and the stuff that's under the Kapton tape is the little battery monitoring system with two FETs, one for under voltage, one for over voltage. Now, I did recently order some 18650s from Amazon, and
Like this, you mean?
yep,
Yeah, they do not. You can get these with a little battery protection circuit. I have some, but this
most
one
of
does
them.
not.
Okay,
You need a BMS for this one. And for this one. This is also, by the way, lithium ion. It's 4.2 volts fully charged, but it's the same size as a double A, which can get really confusing.
yeah.
So here's a
So
double A, right? And
I'll
here's
bet
this thing.
it makes your
They're
flashlight hum.
so
flashlight's
for
probably a good
sure you
application
can
for it.
see it's just a little bit shorter, but not by much.
So
But yeah, this is 4.2 fully charged, and this is 1.2.
yeah. So the 18650s I purchased said they had the battery management chip on them, and I certainly figured they did. They're different lengths, with and without the protection. Because they just take a raw cell and they stack on top of it the protection
Right.
thing, and
Which
so
makes them a little bigger, and they don't fit in the
they don't fit in
normal.
the cell holders. You have to.
Yeah,
You
this
can
cell
buy
holder, they won't fit in there.
you can buy cell holders that fit the raw cells and ones that fit the cells
So
with the thing
I've
on the
been
top.
yanking them out and just using so if you got to put a bunch of them in a bunch, like you've got 4 or 5 cell things, you're going to have an external BMS anyway. I just yank those things off of there. They're useless.
So anyhow, the ones I bought,
Oh, the world is crazy in that case.
it is the ones I bought did not stop at 3.7 or 3.2 or whatever. Um, after my device failed, I checked the voltage and it was like 0.4 volts or something, which is really low and kind of scary for recharging a LiPo that's been discharged that far. My good charger said, no, it's under
Yes,
voltage. I am not going to charge that.
you must
Um,
not try to charge it. That's the recipe.
so, so I tried a cheap charger and it said, okay, I'll charge it. And it brought most of them back to life. But these claim to have the power monitoring circuitry on them. So
way back yonder, I would, if I wasn't sure about the bat, whether it had the protection, I would charge it in a metal can where, okay, go ahead and set, catch on fire. The worst you're going to do is overheat the floor,
yeah, I always
but
do my charging on a tile floor, away from combustible
I do
materials.
my charging in a jar of thermite.
Oh, that's good.
Far more interesting. It tells you if the battery's, overcharged really quickly. It's a good indicator.
Carl, we don't hear you.
well, I was
Oh,
just going to
so
describe something that I've been working on.
Okay.
It's a thing for logging skin temperature. And I have a situation where my temperature regulation is wacky, and I'm very curious to measure it. And the thing that I've learned is that if you buy a breakout board with a really high quality temperature sensor on it, you have to stop and think about the thermal inertia. So this breakout board is order of magnitude 3/4 of an inch square. The sensor is the most ridiculously small little metal can you've ever seen. It's like 2 millimeters square, maybe a millimeter and a half, and it's soldered onto this. It's on this board, and if it's clamped up against my skin, there's so much. It's like it's having to heat the whole
Ground
board.
plane in the breakout
Yeah,
board.
everything is having to get heated, and so it's extremely slow changing, and so
How
I have to stop.
how
Sorry, go ahead.
fast of a response are you
Oh,
experiencing? These are
I'm talking about a change in temperature that's happening over the course of, say, 60 seconds, and the sensor is uh, taking a long time
yeah.
to register that. But this will, well, this might be amusing. I recently found out that when my skin temperature goes out of range, um, I can put my wrist on a cold pack, an ice pack, and it tricks my body into going back to proper temperature. And yeah, crazy. And so I'm doubly interested in getting the logger to work to document that, and to be able to really see the effectiveness of it and so on, because it's something that should be broadcast, because there are
So
a lot of people out in the world that have the same issue where
are
they're
you underheating or overheating?
almost always overheating, but sometimes underheating. And I can fix the underheating by just putting a jacket on. But the overheating, is extreme. But anyway, um, this is a side effect of my cancer situation,
Right.
and but the thing with the wrist and the ice pack is pretty mind-boggling. Um, I'm amazed that it's been like coming up on a year and a quarter before I found out. Oh, just put your wrist on something cold,
Yeah,
Like,
that's life
who
hack for sure.
who knew? Who knew? But anyway, so yeah. But so my plan is to Oshpark offers a flexible PC board option,
Okay.
and I'm going to see if I can surface mount solder the sensor onto a small board that's and calling it a board is a stretch. It looks more like a kind of a thick piece of plastic that's flexible. I shouldn't say thick. It's what is it? It's maybe a couple hundredths, 300ths of an inch thick, and it's quite flexible. And I expect that to absolutely solve the inertia problem. But the sensor is a Bosch BMP 388. Costs about $5 or $6, and the temperature sensor is extraordinarily accurate and it's really good. But it's actually a pressure.
You guys hear me?
Yes, now we do.
Now you came
Because
through.
I
You're
cannot
back.
hear you now.
Well, you can't hear us laughing at you then.
It's one or the other.
So anyway, it's actually a pressure sensor that also measures temperature, and it's so precise that it can discriminate a difference in altitude of just a few feet,
Yeah.
which is crazy. And it is the less performant. You can get a BMP 390 that can discriminate a change in height of like literally a foot or less. So it's pretty wild. But anyway, that's the situation there. And once I get it actually working, I'll share results.
So that's I2C. Does that?
Yes, it
So
well it does. It can
or
do
is that on the
SPI.
breakout board?
It okay.
How
So
many pins on the chip? Is I
I
guess
think it's either 8 or 10, and but it's really small. I mean, we're talking very small surface mount. Um, but it does SPI also, and I got a handful of SparkFun boards only to find out that SparkFun was dropping the product. So this is related. You know, we're messing with these with the Edger project, and Don Trimbeth bought a bunch of DF robot boards, which have the sensor, and they can run either SPI or I2C, and so it's a nice little board, quite inexpensive. From memory, they're $7 or $8. So you know, just slightly more expensive than it costs you to actually buy a quantity one chip,
Yep.
which of course is completely worthless unless you can surface mount solder the thing. Anyway, enough. That's my blathering for the month.
Can you still hear me?
Yes.
Okay. It was the USB connector on the computer itself. I just changed the plug it went in.
Yep.
It worked. But somehow or another, I knocked out my sound, so I had to fix that.
I ought to try that on my camera. Maybe it's the USB port. Although I'm using the same USB port now for my cheapo camera. All right. Any other show and tell or comments or?
I'm still experimenting with my UPS. I haven't looked at it for a while, but with all the power outages we've had in the last week, I figured I better do something about this.
So I get a notification on my phone when the home power goes out. I run my Raspberry Pi on a UPS that has a USB cable. Yeah. And it will, and there's a driver that you can put on the Pi that will get told of events like going off of mains onto power and off of battery back onto the mains.
I'm using a couple of those on RPIs. I rewrote the software for the one that I'm using, all in Python, so it can do logging and all sorts of other things. And I've got it set up so it'll actually run the Pi for 10 minutes on the battery before it decides to shut itself down. So after 10 minutes, it'll just shut down the Pi properly.
Yeah, that's good.
However, it's not quite that easy for my computer and monitors and UPS. Well, what do you call it? Modems and Wi-Fi's and all the other crap I got on it.
Yeah. Yeah, I'm good for a few minutes, but if it runs more than 10 minutes or so, the UPS is
that's
shut down,
usually
and then all kinds of bad things happen to bring it all
right.
back up.
How many volt amps are you using in UPS?
I don't know. It's an APC 350. I don't know what the number means. It's got a 12 volt, 7,000 milliamp hour. So it's a 7 amp hour lead acid battery.
ATC, what is it? 750?
350. 350 UPS, I think. I've got a bunch of different ones, but the one that the Pi is plugged into, I believe, is a 350.
This is giving me a Honda motorcycle. Wrong.
Search UPS 350. UPC, UP.
Oh, it's a UPC. That's right. That's the reason why. So this only uses
350. Yeah.
It only uses a single battery.
Correct.
Yeah, it's not going to be very high power.
But it should run a Raspberry Pi for many hours, I would think.
Oh, an RPI, yeah, but I'm looking for something for my computer.
Oh.
Either I'm thinking about just building one. So I was going to convert my old one, but I don't see any way to do it. They only have 2 wires with a lead acid battery. If you want to convert it to something like lithium ion, which is really much more efficient, takes less space, a lot less heating. The problem is you've got to go up to 42 volts, and this thing only goes up to 40. I could put a power booster on it because charging is only going to be like an amp. So I'm not really worried about putting a power booster on to get the voltage up. The problem is that you need 3 wires, and these things only give you 2. So one is for a lithium ion, you need a common ground, and then your output, and then a charging. And the output and charging cannot be the same. And UPSs are always built with 2 wires, a ground and a charging or power. And it's determined internally with a relay. Okay.
Yep.
The problem that becomes problematic because I can't find a schematic. I could find something close for a schematic, but not the right thing. So theoretically, all you need is an inverter, right? And a power supply. That's all you need.
Right.
And then if you're using lithium ion batteries, you need a BPS. But those are the 3 things that you need in order to have a UPS system. So I've been seriously thinking of trying to build a high power one from scratch, using maybe some MOSFETs on a big fat heat sink, and building my own contraption. Because, be honest with you, I'd have a lot more fun building it than spending $1,000 on a 1,500 or 2,000 volt amp UPS. They're just way too expensive.
I'm told for large batteries, lithium iron phosphate is way more safe than vanilla lithium ion. Yeah, yeah. When something goes wrong with a big lithium battery, it's pretty serious. Um, yeah, it would probably make Nick's thermite look tame.
Yeah, and that may be why it's hard to find them with lithium ion. Try to find a UPS with lithium ion batteries. They almost invariably use lead acid or sealed lead acid, uh, SLA. Um, yeah, so this has been my bane for the last 6 months, trying to figure out how to solve this problem and not spend $1,000. I don't mind spending a few $100 and building it myself. I think that'd be fun, but
How long are your blackouts typically?
it doesn't matter. Once it blacks out, the computer crashes.
Okay.
Those, I mean, I had a couple of real short ones the other day. The first one got me. The second one, I shut it down just before the power went off. So I don't want to have to keep worrying about that, especially if I'm not home. And then I can also build some sort of uh, electronics or something in there to say, okay, the battery's almost dead, shut down the computer. So the APCs will do that for you if you got it wired up right.
Yeah.
But I find they often don't seem to work right. I don't know why. I don't know. Have you ever had it work with yours?
I don't think I currently have any set up. I have done it in the past, and maybe it worked, maybe it didn't. Windows drivers and custom funky cables,
Yeah.
but
What I found with the less expensive UPSs, let's say under $300, I've hooked them up to test equipment and looked at what their charger is doing, and as near as I can see, the ones I messed with, and some of them were APCs. Their charging algorithm is, let's see how much we can abuse this lead acid battery.
Yeah.
The voltage regulation was terrible, and they were basically breaking the rules. Um,
Well, I mean,
that's
that's why you have to buy new lead acid batteries for these things all the time.
Yeah.
They do
I
that
mean,
on
in my
purpose.
opinion, they're not taking care of them. They probably have some kind of deal with the battery manufacturers. And, it seems like, they're, geez, well, of course, they sell batteries, right,
Right.
yeah,
at a
yeah,
huge premium.
yeah.
Um, and so, one factor, in my opinion, is to somehow prevent them from overcharging the battery, because the ones I messed with would chronically overcharge the battery.
Well, and that's what was happening with mine. So they put these batteries into a sealed metal case. There were three batteries, three 12-volt SLAs, all wired in series. I don't know how else you could do three, but yeah, they're all wired in series. It's a 40-volt to charge them, and less than a year, the batteries are toast. It just overheats the batteries. There's no ventilation, there's no fan in that part. There's a fan on the electronics, but nothing for the batteries. There are two little slits on each side. I mean, little slits
To
where
let
air can
to
get
let
in.
the hydrogen escape.
Yeah,
What
well, I mean,
happens?
what happens with overcharging is you lose the hydrogen. You lose the water.
Right.
You lose the necessary
In,
ions
right.
that go along with the electrolyte that it ruins it. It just ruins it. Anyway,
Thermite's a hell of a lot simpler.
yeah, just stick some thermite in there.
Yeah. So
What
that's
about these new lithium power generator replacements? For home house power. Rather
You
than
mean
moving
like
from
the Tesla battery?
no, these are more like the size of a cooler, I think, or a small cooler, and they're meant to be throw them in the back of your truck and take them camping. And they've got an
That sounds,
inverter, and
yeah.
it's just, I mean, just search on Amazon or something for a portable, portable power
Power
pack. Just
That
search
sounds
lithium
interesting.
portable power,
Yeah.
and some have solar panels that go with them. Just a thought.
All right, everybody. I will see y'all later. Sorry for the interruption. I gotta go to sleep for work. But
Sleep well.
everybody.
yeah.
Bye, Haven.
Bye bye.
Bye.
Yeah. Here's the electronics for this thing.
Bunch of capacitors.
Yeah. So they've got a lot of these heatsink things. There's like 1, 2, 3, 4, 5, 6, 12, 24. I don't know if these are MOSFETs or transistors. I'd have to look them up. There's a bunch of coils. There's all sorts of stuff. That's what I was originally going to try to convert, but I'm thinking it's too much work. And that's the case that the 3 batteries went in. I mean, you can see there's a little slit in the back, and then there's these 2 slits or 3 slits on each side on the top, and the battery sits just below where the slit is. So, I was changing batteries every 10 to 11 months or something. I got tired of spending the money.
Yep.
Nick, how big is it?
It's a one of those standard 8x8x14 brick things.
Oh, I think I have one of those. So I've got a couple of real small. UPSs. Like these.
Yeah, that's about it.
Yeah, ATC. Is that a 600 or 500?
Yeah, it's a 500.
Yep.
So I've got like 1, 2, 3, 4. I got 4 of them.
That's what I use on my stuff.
Yeah. So, but this isn't going to power the computer and 2 monitors and all of this other stuff. It just isn't going to handle it.
It'll get it through a 10-second brownout.
Well, just don't plug your monitor into it. I
Yeah,
mean,
you
just
don't
plug the
plug your
computer.
monitor. You don't.
That's true. I mean, I could do this in a snap. I'd probably just plug this in and let it use it without the monitors and everything, and just keep the computer from dying.
So I pasted a URL into the chat that might be what Bill was talking about. It's a 300 watt hour, 299 watt hour home backup lithium battery. It'll supply 110 volts at 300 watts, pure sine wave AC, and it's around $300.
$1 a watt.
And you can recharge it 500 times.
300 watt amps or 299
Yeah.
Watt hours.
watt hours, right?
Yeah, I don't know.
So it,
Oh, that's
Maybe
the
it doesn't
battery.
work as a UPS.
Oh, this is lithium-ion battery. Interesting.
well, the question is, in my mind, is How do you go about recharging it? Can you plug it in to recharge it, or do you need the solar panels that it talks about?
Well, you can definitely charge it via, plugging it into AC. It says that, but whether you can,
Charge it while you're using it.
yeah,
No, whether it'll cut over. You probably need a circuit,
the cutover circuit,
like a single pole double throw relay that drops out. When you're well, of course. No, something faster than that. A lot faster than that.
Solid state relay.
Yeah, it's probably not going to work.
Interesting. Well, this is a thought that I've been having. I've been mulling over how to do this and maybe build something for myself, but I don't know. Haven't decided on anything yet. This is actually a cool idea. If you're going out hiking and camping a lot, I don't know how heavy this thing is though. 12.12 pounds. That can be significant if you're out backpacking.
Yeah, forget it for backpacking. You want a 10 amp hour brick that fits in your pocket.
Yeah, right. That's all you want for that. But this, yeah, you don't want to be backpacking with this sucker.
Yeah, you have to put wheels on it.
Anyway, I'm going to put that link in the notes for the video since we've been talking about it.
All right. Anything else? We'll see some of you guys on Wednesday.
Everybody's invited. It's shaping up to be the ideal meeting to get a handle on what Edger is and what it's becoming and so on and so forth.
Is that at the Forge? Or
Yes,
is that online? Oh,
it's both.
Both.
okay.
Yeah, I sent out a notice earlier around 3:00 this afternoon.
Yeah, I saw that come by.
On Signal.
Yeah, well, both Signal and email to
Email.
TriEmbed.
I saw it on email. Actually, I think I saw it on both. Actually,
I almost sent a message on Signal saying, "Raise your hand if you've let your Signal rot and you haven't updated it." Because I mean, it's one of its obnoxious traits is, you must upgrade. It's like, this is not optional. You must upgrade, and it won't work until you upgrade it. But anyway,
that means they're changing protocols, communication protocols. Well, that's one of the reasons.
I think that they're perhaps just filling in a little crack in the security or something. I don't know. It's extremely serious software. It's really serious.
Yeah, I've actually heard the owner, which is a woman, or the CEO of the company is a woman, making comments about it, and what their purpose and mission is. I was kind of impressed with how the people at Signal take the responsibilities that they created for themselves. Let's put it that way.
Yeah, I mean, in some contexts, it's being used in life and death situations where if you put your foot wrong, I mean, you guys have probably read about what's going on in Iran, for example. You don't want to put your foot wrong in that country.
No. If I went there, they'd put me in jail immediately. Well, that's because
hopefully they wouldn't let me. Hopefully they wouldn't let me in.
Yeah. No, it would be because I'm a Baha'i. They don't like Baha'is there. That's where the Baha'i faith started also.
Wow.
And so there are many, many, many Baha'is in prison there, specifically because they're Baha'is. Anyway, that's a whole other